Hello guys, welcome to your channel Learning Point. We are today continuing with our differentiation chapter, which is chapter number 3 in the new syllabus of your HSC Commerce. And today I am doing exercise 3.1. I have explained the basics of this chapter differentiation as well as the basic of different kinds of functions, composite functions, the rules of differentiation in the previous lectures. So in case if you have not seen those lectures, I would suggest go check out those lectures, and then if you come back to this lecture, it would be very easy for you to understand. I am giving the link of those lectures in the description box. Please go to that, check out those lectures, and then if you see this, it would be very easy for you to understand exercise 3.1, guys. So all those who have already seen those lectures, let us check out the further part of this particular chapter. Let's get started. Come on. Exercise 3.1. The question number 1 tells us that find dy by dx. As I told you in the lecture, in our last lectures, in all the questions of this particular chapter, we will be seeing two types of questions. Either they will tell you find dy by dx, or they will tell you differentiate with respect to x. Either one of them, you have to do the same thing. You have to find the derivative. You have to find the value of dy by dx. So now under this, if I see my first question, it is y is equal to square root of x plus 1 upon x. So looking at the question, I understand that it is in the form of under root of fx. Yes, I had told this to you. Whenever we come across this kind of a function, I get a value inside the square root as fx. So the answer for this, the derivative of this is 1 upon fx multiplied by derivative of fx. And what is fx over here? X plus 1 upon x is fx. So whenever I am finding the derivative, I have to write over here differentiate with respect to x. So the derivative of y, as we know, it is dy by dx. It is equal to, the derivative comes out to be 1 upon under root of x plus 1 upon x and multiplied by derivative of x plus 1 upon x. Now this element is outside the derivative sign, so we leave it as it is. I write over here 1 upon under root of x plus 1 upon x can be simplified by taking LCM by writing it as x square plus 1 whole upon x multiplied by. Now when I take the derivative of x, we know that derivative of x is 1 and derivative of 1 upon x is minus 1 upon x square. Now according to the laws of indices, what I can do is I can separate the square root terms over here. So it will become 1 upon under root of x square plus 1 divided by root x. Second thing, I can take the LCM over here inside this bracket. So it becomes x square minus 1 whole upon x square. Now in order to simplify, just take this root x in the numerator, because whenever the fraction is taken reciprocal, it becomes, this element goes in the numerator. So I get this is equal to root of x upon root of x square plus 1 multiplied by x square minus 1 divided by x square. So that is the very simple sum. Your sum number 1, the derivative is ready. Okay. Let us see the sum number 2, guys. In case if you wish to write, you can pause the video, you make a note of this, and then you go to the sum number 2. So continue with sum number 2 now. It says y is equal to cube root of a square plus x square. A square plus x square. Yes. Now we have a formula for the derivative of root of x, that is square root of x, but we don't have a formula for derivative of cube root of x. So when I come across this kind of a question, what I can do is I can just express this cube root as cube root of a can be written as a to the power 1 upon 3. So in that case, this element can be written as y is equal to a square plus x square to the power 1 by 3. And yes, now I can differentiate this. You got it right. We have to differentiate this with the formula for fx to the power n, and the answer for that is n into fx to the power n minus 1 multiplied by derivative of fx, where this element, the bracket element, is taken as fx. So in that particular case, I have to say differentiating with respect to x. So you know the derivative of y is dy by dx. So I write over here dy by dx. This n into fx to the power n minus 1. N over there is 1 by 3. So I get 1 by 3 into fx, which is a square plus x square to the power 1 by 3 minus 1 multiplied by derivative of a square plus x square. So now over here, this 1 by 3 will remain as it is. A square plus x square to the power 1 by 3 minus 1. When you take LCM over here, guys, 1 minus 3 will become minus 2 upon 3. Now the derivative of the second part. Now in this, a square is considered as constant. Therefore, derivative of the constant is 0. So we leave that part as 0 and I write this 0. Derivative of x square is 2x. So I get 0 plus 2x. So we get our final answer over here, guys. 0 plus 2x is 2x. 2x into 1 by 3, that is 2x upon 3. And a square plus x square to the power minus 2 by 3. This is the required value of dy by dx. As you all know that we have to highlight our final answer, so we are putting that in the box. In case if you wish to write, you pause the video and you can make a note of this. Now we'll go to sum number 3, guys. In the sum number 3, it says that y is equal to 5x cube minus 4x square minus 8x and whole to the power 9. Yeah, so once again I have to use the same formula over here also, which is fx to the power n. We just now saw the formula, it was n into fx to the power n minus 1, and this entire base element is considered as fx. So when I want to find the derivative, you know that we have to write over here differentiating with respect to x. So derivative of y is dy by dx, and over here this will become n is 9, so 9 into fx raised to n minus 1. So I get minus 4x square minus 8x and whole power 9 minus 1, which is 8. So after this we have to again multiply it with derivative of fx, you know that. So I get multiplied by the derivative of 5x cube minus 4x square minus 8x. So this entire element will come down same to same because there is no change as it is outside the derivative sign. Whole power 8. Now the next term, derivative of 5x cube. Once again, I have to take the derivative for this particular term using the formula for x raised to n. And the answer for x raised to n is same as what I applied just now, n into x to the power n minus 1. Now, what is n for the first term? 3. So I get 5 multiplied by 3 x to the power 3 minus 1, which is 2. For the second term also we will use the same formula, x raised to n. So it will be minus 4 into bracket 2 into x to the power 2 minus 1, which is 2x. And the last term is minus 8x. Derivative of x is 1. So I get 8 into 1 is just 8. So when I write my final answer, it is 9 into 5x cube minus 4x square minus 8x whole power 8, and multiply the terms, it gives you 5 into 3, 15x square minus 8x and minus 8. So that is your required value for dy by dx. So that completes your question number 1, guys. I hope question number 1 is very clearly understood to everybody. Now we'll go to question number 2, where the questions over there are based on the formula for log fx. The first question was based on fx raised to n. Now the second question is based on log fx. You know the formula for log fx? It is 1 upon fx into derivative of fx. So let us understand how to apply this formula in our examples. Come on. The first question over there in question number 2. Again question number 2 says to find dy by dx. Under that, the first one is y is equal to log of log x. So when I have log of log x, I consider this term as fx. So it becomes log of fx. So as per my formula, first we will say differentiate with respect to x. Derivative of y is dy by dx. And the answer over here will become 1 upon fx, which is 1 upon log x, multiplied by derivative of fx, which is derivative of log x. So this 1 upon log x is as it is, and derivative of log x is again 1 upon x. So your final answer comes out to be dy by dx is equal to 1 upon x into log x. Let us see the sum number 2, guys. The next question says it is y is equal to log of 10x raised to 4 plus 5x cube minus 3x square plus 2. You got it right. Again, what we have to do is we have to consider this entire term as fx. So when we want to find the derivative, we will say over here differentiate with respect to x. So derivative of y, as you know, it is dy by dx, which is equal to 1 upon fx. So I get 1 upon the entire term inside the bracket as it is 10x raised to 4 plus 5x raised to 3 minus 3x square plus 2 multiplied by the derivative of the fx element. Derivative of 10x raised to 4 plus 5x cube minus 3x square plus 2. So leave this element as it is over here because it is outside the derivative sign. We will once again copy it down same to same. Minus 3x square plus 2. And now I want to find the derivative of 10x raised to 4. This 10 will be as it is. And in order to find the derivative of this term, I will consider the formula for x raised to n. What is the formula? N into x to the power n minus 1 for the first as well as the second and as well as the third term. We will be using the same formula. So for the first term, n value is 4. So I get 4 into x to the power 4 minus 1, which is 4x cube, 5x cube. So I copy down this 5 as it is. X cube, the value of n is 3. So it is 3 into x to the power 3 minus 1, which is giving us 3x square minus x square. The derivative is 2 into x to the power 2 minus 1, which is 2x. The last term is a constant term, and you know that derivative of a constant is always taken as 0. So in such a case, the derivative of last term is 0. So it is left as it is. So now, once again, copy down the entire term outside the bracket. 10x raised to 4 plus 5x cube minus 3x square plus 2. And this over here 40x cube plus 5 into 3 15x square minus 6x. That is your final value for dy by dx. In case if you want to more simplify this, the only thing that we can do over there is we can take out x common from all the terms in the numerator. So I will get over here 40x square plus 15x minus 6 whole upon 10x raised to 4 plus 5x raised to 3 minus 3x square plus 2 is equal to dy by dx. So that's a very simple sum, guys. Sum number 2. Again, question number 3 is also a similar sum. So let us see the sum number 3. In case if you wish to write that sum, please pause the video and you can copy down that sum. You are having y is equal to log of ax square plus bx plus c. Once again, I consider this entire term as fx. So if this entire function is fx, again we will use the same formula log fx. So what we will say is, we will say over here to find the derivative differentiating with respect to x, derivative of y dy by dx, and log fx, as you rightly know the formula, 1 upon fx ax square, plus bx plus c multiplied by derivative of ax square plus bx plus c. Now we leave this 1 upon ax square plus bx plus c as it is. Now what is derivative of a into x square? A is the coefficient, so we cannot do anything with the coefficient. And derivative of x square is with the help of formula for x raised to n, which is n into x raised to n minus 1. So it will become 2 into x raised to 1, which is 2x, plus b into derivative of x, which is 1, and derivative of c is 0. So when I write the final answer, it is 2ax plus b divided by ax square plus bx plus c. Quite easily done, guys, right? So we'll just highlight our final answer. I would expect you do it in all the sums that you are copying down, guys, in your final exams as well as in your school exams, college exams, because highlighting the answer just gives a better presentation of your answer sheet. So always highlight your answers. Now we move on to question number 3. Once again, question remains the same. Find dy by dx. But here the function that you are given is an exponential function. In case of exponential functions, we had seen that there are two cases. It is a raised to fx, which is a raised to fx into log a into derivative of fx, that is one formula. Otherwise, the second formula that we had seen was e raised to fx. And what is the derivative for e raised to fx? E raised to fx into derivative of fx. So either one of the two formulas will be applied depending on what type of question is given to us over there. So the first one, if I observe, it is y is equal to e raised to 5x square minus 2x plus 4. You can observe and compare it with our general formula. It is similar to the second one over here, which is e raised to fx. So when I want to find the derivative, we will write over here differentiate with respect to x, and you know that derivative of e raised to fx is e raised to the same element over here. As you all know, this entire power element is considered as fx, so we have to multiply with the derivative of fx. So derivative of minus 2x plus 4. Now leave this element as it is, e raised to 5x square minus 2x plus 4, derivative of 5x square. I'm sure you can get the answer orally by now. It is 5 raised to 2x, 2 into derivative of x, that is 1, and derivative of 4 constant is 0. So our final answer comes out to be 10x minus 2 and e to the power 5x square minus 2x plus 4. So what we can do is, I can take out 2 common from these both terms. So it will give me 5x minus 1 into e raised to that becomes your value for dy by dx. Just let me erase off this. It has appeared from somewhere. And now we'll go to the sum number 2. It is y is equal to a to the power 1 plus log x. Once again, what we will do is we will say differentiate with respect to x, and you can easily guess the power element over here will be considered as fx. So derivative of y is dy by dx, which is equal to a raised to fx. So the answer is a raised to 1 plus log x into log a into derivative of fx. So multiplied by derivative of 1 plus log x. So I will get the a raised to 1 plus log x element as it is because it is outside the derivative sign. Again log of a as it is, and 1 plus log x, the derivative of 1 is 1 0, and derivative of log x you all know it is 1 upon x. So yes, I get my final answer 1 by x a to the power 1 plus log a multiplied by log a. This is dy by dx. So that is your sum number 2. And the last sum of the exercise, guys, y is equal to 5 to the power x plus log x. Now over here, the power element is considered as fx and the base element is considered as a. So once again, I come across a question which is of the same type, a raised to fx. So I know the formula, a raised to fx into log a into derivative of fx. So when I want to find the derivative, I will write over here differentiating with respect to x. So derivative will come out to be dy by dx 5 raised to x plus log x into log of a, which is log of 5, into the derivative of fx, which is x plus log x. Now we take down these all elements as it is, x plus log x into log 5 into, what is derivative of x? It is 1. What is derivative of log x? It is 1 upon x. And guess what? We are done with our answer. This completes our exercise. 1 plus 1 by x, 5 raised to x plus log x multiplied by log 5. I hope everybody has understood the entire exercise. In case if you have any doubts, you can always send me an email. I'll definitely help you out with your doubts. Thank you for watching again, guys. See you in the next lecture with some other exercise, with some new concepts. Till then, goodbye everybody. Take care.